Okay, I've started the recording, which I usually forget. So this time I started on. Okay. Very good morning, students. Am I audible? Are you able to see the PPT?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. Let's start the lecture. This is very, I should say, basic lecture. We are not going to start actually studying the embedded systems. I should say we'll start next week, most probably, if the time permits. So this basically lecture is I'll give you the idea about what do you mean by embedded systems, what kind of different embedded systems are there, some of their applications, and we'll try to understand as a in a much more broader sense what do we actually mean by it. Okay, like what kind of things is there inside the embedded systems, and based on that I have prepared some questions which you have to answer, and then in the next lecture, I'll go through some of the prerequisite. If you remember, yesterday I was talking about some of the prerequisite like basics of C programming, basics of digital logic design, basics of microcontroller. So we'll study that. And after studying that, we'll start the syllabus. Okay. So is there any doubt regarding the flow of the lectures which will be undertaken? And also, do you guys prefer English or do you want me to speak in Gujarati? See, why I am giving you the option is because I know that English is very important. Okay, as you guys are in sixth semester, at the end of the sixth semesters, you will be probably going for internship interviews. You will also be going for some placement exams, which are early, and basically that the weightage is given to English much more. Like even we think like, even if you want to work in Gujarat itself, then also they prefer that you should be able to converse in English at least for 15 to 20 minutes. And whatever you guys have in terms of technical knowledge, you should be able to convey it in English rather than Gujarati. Okay. So that's why I'm saying that we should talk in English, but ultimately, this is one of the important subjects. Okay. So if I converse in English, 100% English, and you are not able to grasp that technical knowledge, then it's of no use, because in interview, you won't be able to crack anything. Okay. And that won't be because of the language barrier. That will be because of the knowledge barrier. That I don't think so you can afford it right at this moment of your career. Okay, and why I'm saying it is because even if I'm speaking in English and 2 or 3 people are able to grasp, but majority of people are not able to grasp, and they are the ones who needs the technical knowledge the most. Okay, then it's not kind of efficient system. Okay, and efficiency is the key. So please tell me frankly, how do you want me to proceed in terms of speaking English? Whether I should speak thoroughly in English, or you would prefer that I talk in Gujarati, or I'll talk in English, and if you're not able to understand that part in English, you can just write it to me, or you can just unmute yourself and tell that, ma'am, please explain in Gujarati. There are 3 options, okay? And I think there are 14 participants, so 13 students are present. Okay, so I need 13 answers, basically. How do you want me to proceed?
Yes, ma'am. The third option, like you convey all these things in English, but at some point of time where we are not understanding things,
Okay.
that
So,
you please convey it in Gujarati.
okay, okay. But see, in that, I don't mind. Okay, I prefer third option the most. But in that, you have to tell me. Okay, like every 10 minutes, I cannot ask you guys that, are you able to understand or not? Okay. So it is totally dependent on you. Okay. So if you are not able to understand it, then please tell me.
That would be the case in any of the options.
Okay. You have to tell me. Otherwise, I won't know anything. Okay. So we'll go through third option right now. Okay. And then we'll see if you are telling me or not. Okay. Because I'll ask some of the questions, and if all of you are able to answer it, then it's well and good. Okay. Then our system is bulletproof. But if you are not able to answer the questions, then either the teaching is the problem, or the method of the teaching is the problem, or English is the problem. Okay, so we'll go with the third option, and then we'll see how what results are we getting from it. Okay. So majority of you are saying third option, so we'll go with that option first. Yes, Julie, please tell me.
Ma'am, your voice is getting little echoed.
Oh, are you guys getting a little bit of echo? Okay. Yeah, the thing is, in my office, another lecture is going on, so I'm taking your lecture in the lab. Okay. What I can do is, I can open the door and see if the problem is still there. Okay, just wait for 30 seconds. I'll be like that. How about now?
Yes, ma'am, still.
Still?
Ma'am, do you have your phone?
Yes, I do have the earphone.
Ma'am, you are using earphones.
Yeah. Okay, let's not use the earphones. How about now?
Ma'am, it's the same. Ma'am, on earphones, you can cover the mic, so it could be.
Just a moment, please.
Ma'am, the voice is fine if it's not that big of problem.
Okay. Are you guys able to hear me?
Yes, ma'am.
Okay. Is the echo still there?
Yes, ma'am, a little bit, but it's okay.
Okay, so it's little better. Okay. Okay, then let's start the lecture. Okay. First, we'll go through the definition of the embedded system. What actually do we mean by embedded system? Okay. So, as the name suggests, embedded means something that is attached to another thing. Okay. This is the definition of the word embedded. When somebody says the word embedded, that means something is attached to some other thing. Okay. So in our case, what do we mean by something? What is something and what is that other thing? Okay. So generally, the embedded system consists of the hardware and software. Okay. Now that software is usually known as firmware, and that is embedded into the hardware. That means embedded system are the system in which some software will be embedded into the hardware and it will do some work. Okay, why I've used the word firmware is because sometimes when I say that, do you want to be a firmware engineer? And that student is not able to answer that. So he'll ask me what firmware is. Okay. So, and when I'll ask that, okay, then do you want to be, what do you want to be if you don't want to be a firmware engineer? Do you want to be a hardware engineer? And then he'll say, no, ma'am, I want to be a software engineer. Okay. So generally, the software engineer in embedded domain are generally known as firmware engineers. Why they are known as firmware engineers? That is because, okay, if you are using any kind of development board, okay, when if you are using Arduino, you are using TiVa-C microcontroller, if you are using LPC, the Philips microcontroller, whatever development board is, okay, you first you have to write the code, okay. So then the hex file will be created. Then that hex file has to be flashed on your board, okay. And that process, that flashing process, generally if you are using TiVa-C, then we use LM Flash programmer. So that flashing process is known as we are embedding the firmware into our hardware. That is our development, okay. So that's why I've used this definition of the software, which is usually known as firmware. So I hope now each and every student of at least from EC Marwari semester 6 will be able to know what firmware engineer means. Now, little bit traditional definition of embedded system, which we always study first. That is, an embedded system is a microcontroller based, software driven, reliable, real-time control system designed to perform a specific task. Okay, that is the keyword. That microprocessor is general purpose, whereas microcontroller, we perform a specific task. Obviously, in some of the applications should be real time. Like if you are designing a traffic control system, then obviously it should be real time. Otherwise, the system is of no use to us. So we can say that it is a computer hardware system, but some software is embedded into it, which only performs the specific task, which is according to the application, rather than doing all the things. For example, fire alarm system. Obviously, it is an embedded system. It will only sense smoke, and then if the smoke is sensed, then alarm will be turned on, or you can say that you can hear the sounds. Okay, so that is the only thing that microcontroller can do. Why it is such? Why are we saying that microcontroller can do only one thing? Because obviously that microcontroller will be having all the peripherals like ADC, PWM, everything. Then how can you say that it will only do one thing? That is because we have written code, or we have developed the software, or we have developed the firmware which does only this particular thing rather than doing everything. And that's why it will be an embedded system which can only do one thing, which is sensing the smoke. Okay. So how everything will be done? Okay. Like at the, let's say at the system level, what kind of things are, which we as an engineer have to do to perform these kind of tasks. Okay. Then we can say that the microcontroller will be accessing, processing, storing, and also controlling the data in various electronic-based systems. That means in various embedded systems, mainly the part will be accessing, processing, storing, controlling the data. Okay. So in much broader sense, we can say that if you want to explain to some non-technical people, okay, like what do you mean by embedded system? And then if we ask that, how do you achieve that? You know, like hardware system having some software embedded in it, which will only do a specific task. Then if we ask that technically, what do you guys do? Then technically, what do we do? In an embedded system, we'll write the programming code, which will convert the hardware language into software language like C, C++. That means we'll write the programming code in C or C# or whatever you guys prefer. Like in will be obviously microcontroller based. So if you're using Raspberry Pi as your IDE, then obviously you'll be doing it in Python. But if you are using Arduino, then you are using their language. If you are using Philips, then you will be mostly doing in Tile, which is basically C. And if you are using, let's say, okay, I forgot the name, but in that you have to do it in C#. Okay, so basically it depends on the IDE which you are working on. You'll write the programming code in various software languages like this. Will embedded this particular firmware into the hardware, and after doing that, we'll get the result in different format like pictures, text, voice, sound, everything. Okay, that means there will be one hardware. We'll write some programming code which is based on our application or which is based on our need. We will flash that code into our hardware and we'll get the results in form of sound, voice, text, pictures, anything. Okay, so if somebody asks what do you mean by embedded system, then you can say that it is hardware in which software is embedded into it and it performs the specific task. Okay. So, okay, let me ask you one question at this point. What do you think the memory requirement should be in the embedded system? I mean, I don't expect you to give the exact number. I want you to give like, do you need large memory or do you need smaller memory? You are working on embedded system, okay? Let's say you are developing one system in which let's say you are doing only one thing, okay? There is one temperature sensor, and then the temperature sensor, and then we have said something like if temperature increases from 30 degrees Celsius to let's say 35 or greater than 35 degrees Celsius, then AC will turn on. And if it is less than let's say 10 degrees Celsius, then the heater will turn on. Okay, you are developing that kind of embedded system. Okay, it will only perform this particular task, nothing else. Then what do you think the memory requirement of that particular embedded system will be?
It will be smaller, ma'am.
Okay. Okay, I got only 3 answers. Do you think that the answers are correct from Utsav and
Ma'am, program memory would be smaller as a few lines of code we have to write. Yeah, it would be smaller in either case. Data memory would be also smaller. No need of big memories.
Okay. Is Divyesh correct, guys?
Yes, ma'am.
Okay, see, right now there are 13 students, okay? So if there are 13 students, I need 13 answers. So if I ask that is Divyesh correct, that means there should be 12 yes or no. I'm only getting 2 or 3 yes or no. I don't want to, say your name and then ask, okay, that's, you guys are not in first semester, okay? You are not semester 1 students. You guys are already in semester 6. So if somebody asks you the question, you should at least answer. Irrespective of whether your answer is correct or not, if you know the answer or not. Okay? Basically, that is the courtesy which you have to develop. Either you want to remain in academic field or even if you want to go to corporate field. Okay. if somebody asks you the question, you should always answer. If you don't know the question, then you can say that, ma'am, can you please repeat? I don't know the question, or I don't know the answer, or I'm confused, or I cannot listen properly, or there are some network issues, anything. Okay, but at least some answers should be there. Okay, shall I ask by saying names like why Disha is not answering, why Divya is not answering, why Juvi is not answering? Okay, or you will answer. Okay, am I not audible? Is that the problem? Or are you guys getting so much echo that you are not able to understand it?
No, ma'am, you are clearly audible.
Is Disha present in the meeting?
Yes, miss.
Okay. Then I said your name and I asked some question, then why are you not answering? You are not, you have not even given answer in the chat box. Sometimes it happens, okay, if I'm asking and someone has already given the answer in chat box, that's why I have participants list as well as chat box with me. Okay. Okay, so Divya, Shivani, good. They already answered. Disha, do you know the question? Or what are we
એમ
discussing?
મેં આન્સર આપી દીધો છે. આન્સર ક્યાંનો આપી દીધો છે.
Okay, okay. Okay, when Disha, because I'm sorry, I'm not able to. Okay, 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 my mistake. Sorry. Okay, so you guys know at least some basics, but then also let's cover some as well so that I can say that at least I have taken some revision lectures. I don't think you guys clearly need it, but let's just get it over with. Okay. So we can say that if somebody asks what are the characteristics of embedded system, that means characteristic, you can say that if I ask you this question in form of theory, okay, like list some of the characteristics of embedded system. Okay, if I'm not given you the question bank, or if like we were discussing much more in-depth questions like pipelining or ARM v7 architecture, or draw the block diagram of the architecture, and then in the midst of that I ask easy question like define the characteristics of embedded system, or give some characteristics of embedded. There are some cases in which students say that, ma'am, you have not given us the question bank, and I don't know what characteristics are. What do you mean by characteristics? Okay. So at whenever place, okay, anywhere, anytime, if somebody says that give me the characteristics, that means there will be some things which is solely true for that particular thing only. Okay, so if I'm saying that give characteristics of embedded system, not in form of definition, but some characteristics, that means some conditions that, or you can say that some peculiarities which is solely for embedded system, not for any other thing. Okay, so you have to write that kind of things. Okay, that means it is single functions. What do we mean by single function? That means it only performs the specific task which is given. If I say that give me example of let's say pager can be one of the embedded system. Okay, then what does pager do? It will always function as a pager. Okay, repeatedly it will perform the same task for which we have written the code. Okay, so if I say that explain why fire alarm is an embedded system, then what will be your answer? You can unmute yourself or you can write it in the chat box. I don't mind anything. Okay.
Ma'am, please repeat what you asked.
Yes, ma'am. Repeat the question, please.
Oh, yeah, sure. I'm saying defend why fire alarm system is an embedded system. I'm saying that fire alarm system is an embedded system, whether it is true or false. And if it is true, then why it is true. If it is false, then why it is false.
It's true because it's single function, and we have programmed it like whenever there is a smoke of fire, then fire alarm will be active at that time and do the task of sparkling the water over the office.
Okay. Okay. Is Parth correct, guys?
Yes, ma'am.
Yes, ma'am. True.
Okay. Okay. Then how we can say that it is true? Because it is one of the characteristics, okay, of the embedded system, that it is single, it must be single function. Then tightly constrained, okay. This is the most important characteristic of an embedded system. Why I'm saying this is because, like, the aim of designing or the inventing of embedded system is because of this this particular characteristics, okay. Like, obviously we were working on microprocessor, okay, that was not a problem. But then we can say that there were some needs in which we wanted some specific system which was smaller in size, which was fast, which consumed less power. Like, these three constraints were basically the main reason for any embedded system which we created till now, okay? Whether it is ARM7, whether it is ARM4, or whether it is Cortex M0 or Cortex M4, whatever it is. You can say that the base of the reason mostly was tightly constrained, okay? Then what do I mean by tightly constrained? Tightly constrained means there will be some design matrix, okay? As a design engineer, some matrix will be given to you that I need results in form of this, okay? Like the cost should be so and so, the size of the chips should be so and so, the power of the SoC should be so and so, and the performance, that means generally it means how fast it is, what kind of other simultaneous task we can perform. Generally it is based on that in much more broader sense, okay? I'm not going in depth. So we can say that the characteristic of embedded system is it must be of a size to fit on a single chip, must perform fast enough to process data in real time, and consume minimum power to extend the battery life, okay? And why you can say that, ma'am, why this design matrix were chosen, okay? Like, okay, even microprocessor can do the task, then why this particular design matrix were chosen? That is because there was a need in which, like, if we are designing a pager, or if you are designing a printer, or if you are designing a fire alarm system, or even if you are designing the air traffic control system, any kind of example of embedded system, okay, in which we have to, oh, are you guys not able to hear me properly?
Ma'am, we can hear.
Ma'am, clear.
Oh, okay, how about now?
Clear. Ma'am.
Is it clear now?
Yes.
Yes, ma'am, clear.
Yes, ma'am.
Okay, okay. You know what?
Maybe-
I'll try to find the time, and next time I'll be using LAN so that we don't have this kind of problem. Okay. So sorry for today. Yeah. So where were we? The tightly constrained, the design metrics. Why these design metrics are so hard, man? Like, why are we saying that chips should be as small as possible? Power consumption should be as low as possible. And On top of that, it should be a real-time operating system. And on top of that, it should be also fast enough. Okay. Then why this kind of hard design metrics were chosen? That is because we can say that embedded system is a task driven. That means it is single function. Okay. Then if you only want to perform one particular function, then we can't afford to lose as much power as possible. Okay. Like we'll think like, okay, if it is only paging a number repeatedly or naming, or if it is printing the page, or if it is only printing the pages, or we can say that if it is only sensing some things and then some other output is given based on that sensing, then in that we can say that we cannot afford the bigger chip with consuming more and more power. Okay, because it is not like it is not efficient. Like for example, you don't need a quad core processor to design and fire alarm system. Okay, that will be the waste of the capability of the processor. That will be the waste of your time, engineer's time, and that will be the waste of money. Most importantly, like money is governing everything right now. So, okay, so that's why when we coined or when we say that embedded systems should be single function or it should be according to the specific task, then we decided that the design metrics should be harder. Okay. So this is one of the important characteristics of an embedded system. Then the third one is reactive and real time. Okay. Why I'm saying that reactive and real time? I know that all embedded system, there will be some cases in which it shouldn't be real time. Even if it is not a real time, it's fine. But there are many or generally majority of the embedded system in which it should be a real time. Okay. Let's say a traffic controller or fire alarm. If it is not a real time, then it's no use to us. Okay. Then there will be some embedded system which is solely used for, storing the data, and then after so and so we can say that if it is if reach the limit of this, then calculate it and then give me the output. Okay, there are we can say very less amount of that embedded system, but mostly we need real-time answers, or you can say a real-time output. Okay, so that is also the characteristic of an embedded system. What do you mean by real time? Real time means that it continuously react to changes in the system's environment, or we can say that it will react to the external stimuli. Okay, that is also fine. I don't why I'm saying you this is because sometimes when I ask what is real time, some people give me that kind of answer. Now why I'm saying that you can also say that also, because there will be some students who think that okay, whatever ma'am has written in their PPT, I should write only those words, otherwise my marks will be cut. No, it's not like that. Okay, so yeah, but don't expect me to give you the question bank with written answers. Okay, I won't be doing that. But then also, I'll be telling you what important questions can be, or what kind of knowledge is important in that particular chapter, that you should at least know these kind of things. If you say that I understand chapter 1 or I understand chapter 2, but you can write it in your own words, I don't mind. But I expect that if I have given you some theory questions, and which is the 5 marks, then please at least write, let's say half a page. Okay. Explain me in half of a page. Okay. Rather than just using bullet points or the words. I know that you know. Okay. That's not the, I'm not judging you in terms of if I'm giving you, let's say out of 5, if I'm giving you 1 or 1.5, I'm not saying that you don't know. I'm just saying that you are not following the proper procedure. Okay, Why I'm saying all this kind of things in first lecture? That is because I want to set a precedent from start itself. Okay, so after your mid-sem, there shouldn't be any hard feelings between a teacher and a student. Okay, you can write it in your own words. I don't mind, but it should be correct according to the question. And if it is a theory question of 5 marks, write at least half a page. Okay, if you are writing 3/4 or 1 page, then it's well and good. But at least write half a page. And you can write it in your own words. I don't mind. You don't have to use the words which I've kept it in my PPT. Okay, this PPT is not your Bible or Gita. Okay, and if you are not able to understand some topic, even after I'm explaining twice or thrice, then you can go to YouTube, you can go search some blogs, and then you can get some knowledge from there, and you can write the answer based on that. Okay, I don't mind. The main aim is that you should know something, that you should have answer of that particular question, because I'll be asking the questions which are necessary in your let's say in your career. Okay, in much more broader sense. Okay, I won't ask some basic questions which are always asked. No, the questions which you need to answer in your interview, in your placement, or anywhere. If somebody, even if somebody non-technical person asks you, that at least you should know this, I'll be asking those at least questions mainly. Okay. So be prepared. So where were we? Yes, real time. Okay, let's consider the example. Consider an example of a car cruise controller. It continually monitors and reacts to speed and brake sensors. It must compute acceleration or deacceleration repeatedly within a limited time, because a delayed competition can result in failure to control the car. Okay. Now, everybody understands this, okay? But, and majority of you guys know that Tesla has this feature, okay? But do you guys also know that if I've given you this project definition, you will think that, oh, ma'am, it's so easy. You know, like we just have to sense acceleration and deacceleration, and then based on that particular answer, we just have to tell them that whether you should apply brakes or not. Like, how, ma'am, it is so easy. Anybody can do this project, okay? Even if the project definitions are very easy, or you can say you are able to understand or grasp the concept very wisely, then also sometimes the results are not up to the mark. Okay, so when he was when the first model of Tesla was there, I have experienced on first hand that, okay, that my Uber driver was driving the Tesla, and we were just, you can say that there was not even a 2 feet distance, okay, between the cars, and his hand was not on the drive. So he was driving in the automatic mode. Okay, then even even if it was less than 2 feet distance, we were not getting the messages that you should apply the brakes. Okay, so that's why I'm trying to give you this example, which is because why am I saying that it should be real time? Like, you should understand the importance of real time, and you should also understand that it is not easy to design a real time system. Okay, sometimes we can say that it will react to the system's environment in some other way, and not in the way which we are proposing them to do. Okay, like react to changes in the system's environment. If we are designing a car cruise controller, that means you should immediately react to the change, the distance between the car, or if you are if the speed limit is 55, and if you are going 55 miles per hour, and if you are going 100 miles per hour in that particular road, then it's obviously you should get the message that it's not safe to do it. Okay, so it should react to that particular stimuli in the environment. But sometimes it reacts to that particular stimuli, sometimes it reacts to other stimuli. Okay, sometimes it doesn't react at all. Okay, so I know you know that what real-time systems are, but you should also know these kind of things in real-time systems. Okay, then you will have the much more broader knowledge on the subject. Okay, let's go to the next point. That is, it should be a microprocessor or microcontroller based. Obviously, in the hardware part, it should be at least one or the other two. Then in memory, it must have a memory. Why it must have a memory? Because because whatever we have written in either in C or Python or anywhere, our code, we have to flash the code on the hardware, and for flashing we need memory. Now it does not need any secondary memories in the computer. Why I'm saying that it doesn't need a hard drive. Okay, you don't have to store your data in the particular system. It only needs a small amount of memory in which we can flash our firmware. It can for storing, for controlling, for accessing. Only those kind of needs are there, memory wise. Okay, you don't need the secondary memory. Then connected. Why I'm saying it must be connected? It should have peripheral devices, right? Because if it is not connected, or if you can say that we don't have GPIOs, then how will we able to connect our input devices like sensors or ADC, or if we don't have the that I forgot the word, sorry. Like sometimes we need a serial to RS-232, right? Some ID does not come, some ID does not have inbuilt a particular thing. We need extra hardware or extra additional circuit to do some kind of things. So if we don't have the GPIOs, or if we don't have the peripherals, then we cannot design the embedded system. Because designing an embedded system means we need to sense something either from the environment or from the system, and then based on that sensing or based on that data, we should take some action. Okay, and then that action should be in form of output devices. Okay, output devices means it can be flashing the picture, it can be sound as an alarm or buzzer or something, or it can be a voice that you need to do this, you know, like a reminder or something like that. Okay, so we need to connect input and output devices in order to say that this is an embedded system. Okay, and there are hardware and software systems. Obviously, like we need hardware for the performance or for doing the things, and for the security as well. And we need software for let's say the specific task, that means features. We also need to do, sometimes we say that it is only doing one specific task, but it has more number of features. Okay. What do I mean by, let's say, I'll only continue the example for fire alarm. Okay. So generally, the fire alarm, when we say that let's design a fire alarm system, that means what we do is in the input side, we'll be sensing something. And in the output side, we'll sprinkling the water or something. Okay. But there might be, in your project definition, we can say that we need additional features. Now, what that kind of additional features can be? Those additional features can be the flexibility. In terms of flexibility means like it shouldn't give false input. Okay, sometimes it happens, but we don't need that. We want the efficiency to be more than 90%. So it should be flexible. Then in terms of more features, it means that if that alarm is ringing, or if we want to sprinkle the, let's say, water 5 to 6 times per week, that means something is not okay. That means someone is smoking in the non-smoking area. Every time it's not the fire. Okay, then we need that particular data to send somewhere or to store somewhere, and then we need to compute that data, and then based on, by analyzing the data, we need to take some action. Okay, so for that, or how can we do it? Obviously we'll do it from the software part. We won't be doing it from the hardware part. Otherwise the hardwares are mostly costly. Okay, but it is less costly to have the coding knowledge to do it from the software point of view. That's why software is in demand mostly. Okay, so even if it is a specific task, we can add more features to enhance our embedded system. Okay, so when I say that embedded system should have more features software wise, that doesn't mean I'm saying that it should perform more than one task. Okay, are you able to understand that part? Because otherwise I'll be teaching something else, understanding something else. Okay, so mainly when you are going through the PPT, you should understand these kind of things. You shouldn't just read it and memorize it or anything. Okay, then you want, then what will be like? Like, I like practicals, I like lab, but I don't like theory. Why you don't like theory? Because your way of learning things is wrong. Okay, that's why you don't enjoy theory. Otherwise, to design the system, you should have the thorough knowledge. Otherwise, you won't be able to develop any kind of solution in any lab. I'm sorry to say that. Okay, so if the learning procedure should be like that, you don't have to memorize everything. You don't have to remember everything. You have to understand, and understand in terms of what? That you should know each and every word, how it is affected to the subject which you are studying. Okay. And why I'm saying all those kind of things is because right now you have so many opportunities to learn theory. Okay, you can go, you can do book courses, you can see the blog, you can go on YouTube and you can understand it. But the main part is whatever that guy is speaking, you should be understand that part and understand in what way, understand it in a right way, so that it helps you to apply that particular knowledge in some way. Okay, otherwise it's of no use. We can say that yeah, I mean he or she is an average engineer. Why somebody says he or she is an average engineer, that doesn't mean he or she is not knowledgeable. No. We are not commenting on his or her knowledge. We are commenting on the capability of applying that knowledge. Okay. And why the applying part is important? In the engineer career, the applying part is important. Where in some other career, the remembering part is important. Okay. Or in some other career, the creative part is important. So whatever you have chosen the path, you should know that what is the key process to do it properly. The key process to do it properly is you should be able to apply the knowledge. So to apply the knowledge, first you have to gather the knowledge. To gather the knowledge, then you have to analyze that knowledge, and then you can apply it. So this is the process to do it. Why I'm telling you this is because you are only, there are hardly 13 to 15 students. Okay. So in a batch of 13 to 14 students, if you are not able to perform very well in Viva, or if you are not able to perform very well in your interviews, that means either I'm not capable or our methods are not matching. Okay. You can have a different method from what I'm saying right now, but the method should be in such a way that you should be able to apply the knowledge. That is the keyword here. Okay. So you should always know the why and how of any particular point in my PPT. Ma'am, why reactive, why real time, how real time, what kind of example of real time, or what kind of constraints are there on real time, or what kind of problems can arise by real time, those kind of things. If you can understand that, then it will be very easier. Now it is like, if you have understand it like that, that it should be single function, but why it should be single function, or how it can be single function, or why the design metrics are so and so, why the design metrics are so tightly constrained or so hard to achieve, how can we achieve it, what kind of basic blocks are there. And then if I say that write a theory of 5 marks on the characteristics of embedded system, you don't have to memorize anything. You will already be knowing that, okay, embedded system should be like this, it should be like this, otherwise it can't be an embedded system. Okay, or otherwise it can't be an efficient embedded system. Like, you don't have to memorize, you don't have to learn. You just have to pay attention to the lecture, and then just once you have to analyze that particular knowledge which you have got. It's done. You don't have to, after that, you don't have to do anything. Your mind will be easily remembering. Okay, but if you are going to, okay, I should write everything in the assignment also, then I should, remember everything, every PPT or every slide of the PPT I should remember. Then in that part, it's, I mean, you won't be getting 30 out of 30. But in this particular way, if you are writing it in your own words, and this is only for my subject, okay? Because there will be some faculties which will be saying that you should follow that procedure, or you should write this particular word if I'm asking you this question, okay? Then you won't be get marks by doing this. But in this subject, you can do it easily. You can write it in your own words, it should be correct. How you are getting your knowledge is not important. You should be able to apply that knowledge. That is important. Okay, so you don't have to write it every time, or you don't have to remember every slide of my PPT. There will be some PPT in which any of the slides are not important. We just have to go through it. Okay, like this, you might think that, okay, these slides are not important, but it might be important in theory part. Okay, because in mid-semester, I have to ask some easy questions. Okay, so these are the easy questions which I can ask. So in that way, it is important. Not sometimes, if you already know the things, then it is not important from that perspective. Okay, but there might be some cases in the future that it is not either useful by any means. It won't be important in exams also. You already know that part. Then why are we doing it? We are just doing it in order to link both the concepts. Like concept number A, concept number B. For linking both the concepts, I will be using some slides, okay, which is not important. But you should know that why the slides are there. But you don't have to remember it. You don't have to analyze it. You don't have to do anything. Okay. So you should learn like this, rather than just remembering everything, or rather than just going through the books and writing everything, or going through the easy solutions. I don't know. So rather than doing it, do it like that, so that you will be able to remember. Why I'm telling you is that is because sometimes in interview, what happens is, okay, you are able to very well, you are able to speak in English. Okay, that is given. Let's say you are able to speak in English. Mostly, obviously, everybody will be interested in your projects. So you are able to convey the projects very easily, and everything is going good. But then sometimes it happens is they'll ask you the hard questions. Okay, some twisted questions in which your logic will be tested. Sometimes it happens. Sometimes it happens that you won't be able to grasp that logic. You won't be able to remember that logic. You are not able to answer that question. Okay. Then after that, what he or she will do is that he or she will just for the sake of the security that you are, you know the theory, he or she will ask you some basic questions of that particular subject. If you are able to answer it, then it's like, it's okay. Okay, he or she will cover it up. Even if it doesn't remember right now, that's fine. It's not important. So sometimes what happens is you are focusing in the interview. You are only focusing on your project. You are not focusing on the theory part. You are even in the theory part, you are just remembering everything from the book. Then at the correct time, you won't be able to answer even the most basic question. Okay. So if your learning methodology is like that, that you ask why, you you always ask how, then you will be able to remember it, and you don't have to mug it up. Basically, you don't have to mug it up every time. You can understand everything, you can apply everything. So in these kind of instances, it will help you. Okay, that's why I'm asking. But even if you don't want to follow that procedure, that's fine. I'm just letting you know that this kind of procedures exist so that it will be easier for you. Why I'm saying it is because this is not a 100% practical course. Okay, if this was a 100% practical course, then I won't be giving you this kind of advice. Okay, but why I have to do is because I have to take some theory exams of you guys. And I clearly know that you are very capable in the practical part. You will be able to do the lab experiments very easily. Then you should also be able to perform very well in theory as well. And in a way that it will help you in your interview or gate preparation. That's it. Okay. I think, do you guys have some extra minutes, or I should just left the lecture right now and we'll continue after, let's say on after next to next day? Or do you have to study some more, like for 10 minutes? Then we can just go through the types of the embedded system and then we can leave. I need answer from you guys.
And we are having next lecture.
Okay. Okay. Then can you give me your attendance in the chat box? Please write your roll number as well, okay? Name and roll number. I mean, for example, yeah, like that. Thank you. Okay, I'll stop sharing. Okay, and one more thing. Those who have not written their roll numbers or even their names, they are just present in my lecture and they've just answered some of the things which I have asked. I won't give you the attendance, okay? If I tell you to give attendance, that means you have to give the attendance. I want to be checking thoroughly the whole chat box, okay? Yesterday it happened in one of the orientation lecture and I had to take the attendance, okay? So I had to search the whole chat box. Sometimes you have not written your attendance during the attendance time, but you have answered some of the questions, okay? So don't do that, at least in my lecture. You won't be able to get the attendance. Okay. Thank you. Bye-bye, guys. Have a nice day.